In the middle of December 2025, as an ancient visitor from another star system was speeding back out of our solar system for good, NASA pointed the most powerful telescope humanity has ever built directly at it, one last time, and caught something no instrument had ever detected on an interstellar object before. Not a shape, not a structure, a specific gas, escaping from deep inside its frozen core in a quantity nobody expected, confirming that this object was built somewhere, and sometime, almost unimaginably different from anything in our own solar system. This is what NASA and the James Webb Space Telescope actually found when they looked at 3I/Atlas in its final weeks in our part of the galaxy, and why the answer is turning into one of the most significant chemistry results in the short history of interstellar object science. First, a quick word on what this object even is, because the story only makes sense with the full context. On July 1st, 2025, the NASA-funded Atlas Survey Telescope in Chile detected a fast-moving object out near the orbit of Jupiter. And within days, astronomers confirmed it wasn't part of our solar system at all. Its orbit was hyperbolic, meaning it arrived from interstellar space on a one-way trajectory and would leave again the same way, never to return. It became only the third confirmed interstellar object in the history of astronomy, following Oumuamua in 2017 and Borisov in 2019, and it immediately became one of the most closely studied objects ever to pass through our solar system, tracked by an enormous coalition of NASA assets, including Hubble, Webb, the TSS Planet Hunting Telescope, the Swift Observatory, the SphereX mission, and even the Perseverance rover sitting on the surface of Mars, along with the Psyche and Lucy spacecraft, which happened to be in the right positions to catch glimpses of it as it passed. 3I/Atlas made its closest approach to the Sun, its perihelion, on October 29, 2025, and by mid-December, as it was speeding back outward, away from the Sun and away from our solar system for the last time, NASA turned Webb's mid-infrared instrument toward it for one of the most detailed chemical readings any interstellar object has ever received. The observations happened across two separate sessions, the first on December 15th and 16th, when the comet was already about 205 million miles from the Sun, and a second follow-up on December 27th, when it had moved out to roughly 236 million miles. What Webb's instrument found in that window, described in a study published in the peer-reviewed astrophysical journal Letters, was something that had never been directly confirmed on any interstellar visitor before: methane gas, actively escaping from the comet's core. Here's why that detail matters so much scientifically. Methane is an extremely volatile compound, meaning that once it's exposed to even modest heat, it converts from solid ice directly into gas almost immediately, far more readily than water ice does. If methane had been sitting exposed on the very surface of 3I/Atlas the whole time, it should have already burned off and vented into space during the comet's earlier, closer approach to the Sun, long before this December observation ever took place. Instead, Webb detected it showing up late, well after perihelion, as the comet was already cooling and moving away. That timing told researchers something specific and important. This methane hadn't been sitting on the surface at all. It had been buried, sealed away beneath the comet's outer layers, protected from the Sun's heat, until that heat finally worked its way down deep enough, weeks after the closest approach, to reach it and release it. And when scientists compared how much methane was escaping relative to how much water vapor was present, the ratio turned out to be surprisingly high, with, in the researchers' own words, few similar comparisons found anywhere among the comets that actually formed within our own solar system. That same round of Webb observations also reconfirmed something researchers had already suspected from earlier data collected back in August of 2025, when Webb first turned its instruments toward this object shortly after its discovery. 3I/Atlas was releasing an unusually large amount of carbon dioxide relative to water, one of the highest such ratios ever recorded in any comet, solar system, or interstellar. Seeing that same unusual carbon dioxide signature confirmed again months later alongside the newly detected methane gave researchers two independent, reinforcing pieces of evidence pointing toward the same conclusion. This object simply did not form under the same chemical conditions that shaped the comets native to our own solar system. And then, just days after that methane paper, an entirely separate and even bigger revelation arrived. On June 22, 2026, a team of researchers published a study in the journal Nature, using the same trove of Webb data, this time focused specifically on the ratios of carbon and deuterium, a heavier form of hydrogen present in the comet's chemistry. Deuterium ratios are especially useful to astronomers because they act almost like a chemical clock, varying in measurable, predictable ways, depending on how cold and how ancient the environment was where a particular icy object first formed. When the team worked backward from what Webb had measured, cross-referencing those specific chemical ratios against models of how such compounds accumulate over time in different galactic environments, the number they arrived at was almost hard to fully process. 3I/Atlas appears to be somewhere between 10 and 12 billion years old. Sit with that figure for a second, because it's worth actually understanding the scale of what that means. Our own solar system, Sun, Earth, every planet, moon, and comet native to our own neighborhood, is about 4.6 billion years old. This object, drifting briefly through our solar system before vanishing back into interstellar space forever, appears to be nearly 3 times older than our entire solar system combined. If that age holds up under further scrutiny, 3I/Atlas isn't just an interesting visitor. It's very possibly one of the oldest individual objects any human instrument has ever directly measured, a genuine relic from an era of the galaxy that existed long before our own sun had even begun to form. Piecing together the methane finding and the age finding side by side tells a coherent story, even if it's one still being actively refined. An object built from ice that formed in an extraordinarily cold, ancient environment, likely in the outer reaches of some long-vanished star system from an earlier generation of the galaxy, would be expected to trap volatile compounds like methane deep within layered ice, compounds that would only be released slowly as heat finally worked its way down through those layers during a rare close pass by a star, in this case, ours. Everything Webb measured lines up with that picture. The buried, delayed methane release, the unusually high carbon dioxide content, and now, backed by hard isotopic evidence, an age old enough to place this object's formation closer to the birth of the Milky Way itself than to the birth of our own solar system. It's worth being precise about what has and hasn't actually been confirmed here, because that distinction matters. The chemical measurements themselves, the methane detection, the carbon dioxide ratio, the carbon and deuterium ratios used to calculate the object's age are direct, peer-reviewed, published results from real Webb data, not speculation. What remains, as with any single data point in a brand new field of study, is refinement. Researchers will continue testing and cross-checking that 10 to 12 billion year age estimate against other lines of evidence as more analysis of this same dataset gets published. Since 3I/Atlas itself is already gone, too far now for any telescope to gather fresh readings from, meaning every future refinement of this story has to come from the data already safely in hand. Webb's December observations captured one more detail worth mentioning, because it rounds out the full picture of what was actually happening to this object in its final visible weeks. As 3I/Atlas continued moving away from the sun, Webb recorded a sharp, steady decline in overall gas production, with water vapor specifically dropping off, the fastest and most noticeably of all the gases being tracked. That's expected, ordinary comet behavior, water being less volatile than either methane or carbon dioxide, meaning it's the first of the three to effectively shut off production as the surface cools with distance from the sun. It's a small detail, but it matters, because it confirms that everything else Webb measured, the buried methane, the carbon dioxide excess, wasn't some instrumental fluke. The comet was behaving exactly as physics predicts a genuine icy body should behave as it retreats from a star, just built from materials and shaped by an age, unlike almost anything ever measured before it. 3I/Atlas is gone now, continuing outward on the same one-way hyperbolic path that first brought it briefly through our solar system, never to return, its light already fading past the reach of most telescopes tracking it. What NASA and the James Webb Space Telescope managed to capture in those final observing windows, in mid to late December of 2025, and in the analysis published through the following spring and summer, represents very possibly the most complete chemical portrait humanity will ever have of an object built somewhere else in the galaxy, at some point closer to the galaxy's own beginning than to our sun's. A brief visitor, passing through, gone in under a year from the moment of its discovery to the moment it slipped back out of reach, but not before confirming, in hard, measured data, that it carried inside it ice and gas that had been sealed away, untouched for roughly 10 billion years, waiting for a single, brief pass by a star it had never encountered before, and would never encounter again. If stories like this, the ones where real telescopes catch real evidence of something older than our entire solar system passing quietly through our neighborhood, are what you come here for, stay close, because there's more still arriving from the dark, one confirmed discovery at a time.